your host for teaching you domain. So the definition of domain is the domain is the possible input value for the function. And in graphic way, it would be the x-axis. The domain is the set of all possible x values which will output the y value. So there are two types of domains. There's a discrete domain and there's a continuous domain. So the discrete domain is a set of input that consists of any certain numbers. And a continuous domain is a set of input that consists of any numbers. So if you see that the continuous domain, you can see that how they're everywhere, which means they could have any, they could use any type of numbers. But if you see at the discrete, you can see that it's they're in a row. And the numbers for the continuous domain, when you see at the red, you can see that they're gonna be using the same domain for for the blue, the red, and the yellow. But when it comes to the discrete, you see they're all lined up, which means there's no domains repeating, which means that they're all gonna be function. And then which brings me to here. So how you know if something is a function or non-function? Function is like this. So if the x value, which is the domain, is repeating, but if you get different when you have a table and stuff like that, and if you get different, if they have a different output, if they have different y-axis, that means it's not a function. Because when it comes to a function, it should only have one. It should only have one output. It could, let's say, and it should have only one input. I'm sorry, but it should have only one input, because if the input repeats, then it should have the same output based on the pattern that you're supposed to have. So if you look at the graph, when we have look at the table, it says -1 is the x-axis, and then the -2 is the y. And then we have 0 and 2. So to get from -2 to 2, you have to add 4. And then when you trying to go from -1 to 0, you have to add 1 basically. And then you have a pattern there. But when it goes back to -1, so from 0 you're subtracting 1. But then the problem comes here. So if it's gonna go, so first you were adding, if now you're subtracting, you should get -2 again, but you got a -3. And then that shows you that it's gonna be a non-function, because if you have the same input, you should get the same output. And then when you look into the graph, when you have the same input, I'm just gonna have the same y-axis. So if you see, it's in the -1. For those 3 lines that dots that you see, they're in the 1 in the x-axis, right? But then when it comes to the y-axis, they're all separated, but it's still sharing the same domain, which makes it a non-function. If it's a function, it should have the same output, and then the domain should not be repeating for different outputs for a different range. And for example, let's do an equation. So when it comes to the equation, let's say there's an x, which is the domain, and then there's a y, which is the range. When it comes to this, there's an equation. So you should know by now, but it's the y equals to mx plus b. So when it comes to this, let's say we start at 0. We should always start at 0. And when it comes to solving domains, we have to do the literal equation way, because the domain is the missing value when it comes to the equation. So it would basically be the x right here. The x's that's missing right there. So each of these are going to get the number, as we will get into it later as we go on. So let's say 0 is 2, and then 1 is 4, 2, 6, 3, 8. So 0 is 2. And then when it comes to b, it's the y intersects. So it will be y equals mx plus 2. Right? And then to get bm is the pattern. You could go this way or this way. You could use any type of pattern that way. You use the one from the y, or you can use the one from the x. So let's do this one because I think would be better. So to go from 2 to 4, you add 2. From 4 to 6 plus 2, and then from 6 to 8 plus 2. And then this way it's just adding 1, 1, and 1. So when it comes to since the pattern is that you're adding 2, so the m, which is the slope, would be 2. Y equals m. Oh, sorry, I made a mistake right there. It would be 2x plus 2. And now let's go to solving it. As you should know by now, that this x right here is the numbers that are on the side. So you would like replace them. So if you say y equals to 2 times 0 plus 2, you would have y equals 2 times 0 is 0, plus 2 is 2. See, like when you do it, you're going to get your y. And if you don't, there could be you might be making a mistake. Let's do another one using the same one. Y equals 2 times 2 plus 2. So it would be y equals 2 times 2 is 4 plus 2 is 6. So you would get 6. So as you see, out for our x we had 2, right? And then when we solve it, for y we get 6. So, and then if you do that and then you get a different answer, you could be making a mistake when you're writing, which is why you have to be careful as you write, and you have to check your numbers, because a lot of times we might think that we're writing what we're thinking, but sometimes we can make a mistake or even like forget the negative sign or stuff like that. So thank you for listening to this side, and yeah, bye.
Hello, I'm going to be showing you non-functions and functions on a graph and how to find them. So here I'll be showing you. So see, I'm going to be citing this. And this is a non-function because it has 2 on the same line. And for it to be a function, it only has 1. It can't have 2, or 3, or 4, or 5. You get the point. Oops. So see, this whole thing is a non-function. And so, right there, that is a function. So let's see, I'll show another example. This is an example of a function because, as you see, it is only 1 point on the graph, on one line. Let's continue. Here, exactly, this is a function too. Because it's one line. Let's see. Let's go through each point. This is a function because see, there's only one point. This is a function too. This is another function. See, there's one point there. This is a non-function. This is a function. This is a function, and this is a function. But since there's this non-function, this whole graph is a non-function. What do you think? Take a minute, look, and then I'll tell you if you're right or wrong, if it's a function or a non-function. Okay, as you can see, there is 2 points on this line. So that would be not a function.
Today I'll be teaching about what relations and functions are. The point of this video is so that you can learn math in a very simple and easy way. And just so that you remember, you're always free to rewind if you forget or lose track of what I was saying. Now let's continue on to this brief lesson. So first we need to figure out, what is a relation? Well, in a relation, you have a set of numbers that are kind of like the input to your relation. This is called the domain. Handwriting might not be the best, but we get it. There's the domain. Those are kind of like the input to your relation, right? So let's say in our input here, we're just going to draw like a circle. Maybe it's a really bad circle. We'll just have the number 1, okay? Just have the number 1, right? But also, there are numbers that are viewed as the output of your set of numbers, and this is called the range. I'm going to put range over here. Very sloppy as well, but we're also going to draw another circle. And let's say the number in this range that we're going to use is 2, right? So that means that in this set of numbers that we have, where I have a set of numbers is 1, 2, right? Because these numbers relate to each other. Now you could also have another set like 2 that also relates to this number over here, 2. So then it would be the same thing here, 2 and 2. So then maybe let's say we have relation here, our domain is our input number as 3, and our number in our range as -5. And these numbers also relate to each other. So right here, we would put 3, -5. And then that would be the end of it. This right here, these set of numbers that we have here is a relation, and it is also a function because all the numbers here relate to all these numbers here correctly. So this is a function. So as you can see here, that in our relation here, as I show that we have our input number called the domain, our output number is the range. They are correctly related to each other. 1 and 2 both relate to 2, and the 3 relates to to the -5, and we have our relation right here with our set of numbers of 1 and 2, 2 and 2, and 3 and -5. Now right there was a very quick and brief example of what a relation and functions is, and I hope that this video helped you. Remember, if you missed a step or anything about what it is, the input and the output, or think of how I did it, you can always go back, rewind back into the video, and look back at what it was. Thank you very much for watching this video.